body effect is one of the important effect in MOSFETs. We can see that here is an N-channel MOSFET. It has a source, it has a drain. So what happens is when you apply a potential, there will be some channel will be forming over here. So at till some point, some ions will come like this, because it's since it's a N-channel MOSFET, it is P-type, and this is N plus, this is N plus. So some Na ions will come over here, and after that these electrons will come over here. Then the current will conduct like this. So since we are considering the body is grounded, we can neglect the body effect in normal cases, but sometimes there will be a connection between the body too. So there will be some potential called VSB, which is between source and body. So in case this VSB is negative, which means we know that this is N plus, this is P. So which is negative means we are connected like this is negative, this is positive like this. So since this is a forward bias positive, so I mean this is forward biased, what will happen is, so the current will flow over here. So what we mean to have is the our aim is to direct the current from source to drain. The current has to flow like this. But what really happen is there will be a leakage current like this, since this is a forward bias between the body and the source. So this leakage current causes power dissipation, and also a leakage current. This effect is not desired. So we will never forward bias like this. But when it comes to reverse bias, so something like this, we're giving a something like this. What will happen is there will be a reverse bias which causes a depletion region to come over here, a depletion region. So this depletion region keep on expanding to both sides as we increase this potential. So what will happen is, we know that inside depletion region, suppose a PN junction, we know that inside depletion region there will be ions, like this since it's a Na or Nd, will be ions like these. So this won't contribute to the channel formation over here. The channel formation is due to the electrons in case of a N-channel MOSFET, but since this is ions, it won't contribute to the channel formation. So as we increasing this VSP, this reverse potential, this depletion region keep on increasing. As the more the VSB, the availability of free electrons for channel formation will be very less. So it will be harder to turn on the MOSFET. That's why when there will be a VSB which is negative, the VTH, which is the threshold voltage, which will go on increasing. That's basically the body effect. Now we know that the threshold voltage is, in case of MOSFET like this, we have this metal, this oxide, and this semiconductor. There will be some potential current psi ox, which is between the oxide, and there will be a psi s due to this depletion region over here. So there will be a bulk concentration and a surface concentration. Due to this difference, there will be some potential called phi s. So the threshold voltage will be this Iox plus psi s, and also there will be a flat band also there. So for now we are not considering these. So we have this Iox and psi s. So the total VTH will be psi s plus 1 by Cox plus 2 psi s q and epsilon s, and this psi s will be 2 phi f in case of inversion. And in case of this body effect, the VTH going to be VTH 0 plus gamma times square root of psi s plus VSB minus Vs. So what will gonna happen is, if this gamma is very high, then this MOSFET is highly sensitive to the body effect. Even small change in the VSB can alter the VTH, and if gamma is low, then the MOSFET is robust. So this is all about body effect.